Okay, we're going to talk about solving systems of equations, which systems of equations just means finding where two or more lines cross. So really you could have 5 systems and figure out where all 5 lines cross, but you're only going to have 2. And really the most we ever do is 3, and that's like way far. So for 2 lines, if they're going to intersect, there are 3 different situations that will happen. So if I have my graphs, I'm going to draw 3 graphs. Alright, they went great. Okay, the first situation, there will be one solution if I have 2 lines that intersect one time. If you have 2 lines, it will intersect one time. Remember we had discussed if the slopes are different. So if the slopes are different, it will intersect one time. So let's say I'm just going to draw random lines. So these lines intersected right there. So those have one solution. Okay, now if I have 2 lines with the same slope, which means they're parallel, they're never going to cross, ever. No matter what you do, if they have the same slope, you can't magically bend them. They're not going to intersect, so you will not have a solution. So it's no solution. Which a few days ago is why you got an answer. I don't know if you remember the problem I helped you with, is that once you got them alone, you could see that the solutions were the same slope, and so you know that there's no solution. So as soon as you can tell that the slopes are the same, which it has to be in y equals mx plus b form to know that though, then you know, okay, there's no solution because it's never going to cross. Okay, the third one would be is if I have a line, and then if I have the same exact line and it crosses again, then that means that you're going to have what's called infinitely many solutions. And the reason why that's infinitely many solutions is because if we have one line and they're asking you what is the solution, meaning where do these 2 lines cross? If I have one line and then the other line is exactly the same, then it crosses at every single point. So for every x that we plug in, we will always get the same y on both of those lines because they're exactly the same. So these 2 lines will always be intersecting. So we have so many points that could be our answer. So it's infinitely many solutions. Now I'm going to show you a trick to kind of show how you can tell what you're getting at the end, which I'm going to go into next. But this is just a little preface of it. So when we're solving and going through, like I think you learned today, solving linear systems by the addition theorem, then on this one you'll end up being able to solve for x or y. So you'll be able to get x equals 2. And then you'll be able to get y equals a random other number, I don't know, 4. Doesn't matter. So you'll actually get answers. When you're working with a no solution, when you're going through and solving that, you're going to end up getting something like 0 is equal to 5. Which 0 is never going to be equal to 5. We can't do anything to make those 2 numbers equal, so it's no solution. Or you might get negative 8 is equal to 3. Negative 8 will never be equal to 3, so that's no solution. So if you have 2 numbers that are not equal to each other and there's no more x's involved, so we can't do any adding or dividing to kind of manipulate it a little bit, then it's no solution because we can't magically turn a number into a different number. Okay, and then infinitely many solutions would be if you get 0 equals 0, which is true. 0 does equal 0, or 5 equals 5. Or 7 equals 7, or 8 equals 8, or negative 100 equals negative 100. If it's the same number on both sides, then that's infinitely many solutions. Okay, now the first way that I showed you on these is by doing it graphically. So that's always going to be your best bet. And I think a lot of your questions that your instructor was asking you to do was to solve it graphically so that you can kind of see the picture of it. And then you'll get into more solving like you did, like you said on Friday. So let's try one graphically, and then I'm going to move on to the other kind of ways that you're learning, because I think those are a little bit more difficult. So let's say that we have 6x plus 2y equals -4, and x plus y equals 2. Sorry, I wrote these ones down before. Okay, so for this one, we're going to have to graph it. And in order to graph it, it has to be y equals mx plus b, meaning y has to be alone, which is not the case on either of these. So let's work with this one first, and let's move it into slope-intercept form. So I'm going to rewrite. Actually, I'm going to erase this one so that I can do both of them. Okay, so I'm going to minus 6x. So then I get 2y equals, okay, that one has an x, that one doesn't, so they can't combine, so I just write it as -6x minus 4. And then we have to divide everything by 2. So then I get y equals -3x minus 2. Okay, let's go graph this one, or sorry, get it into slope-intercept form. So then we're going to have to minus x. So then these are not like terms. So I can write it as 2 minus x, or -x plus 2. Since that's a positive 2, we can write plus 2. Okay, so if I'm looking at these right now, I'll look at the slopes, which this one is -1, and this one is -3. So these are going to cross one time. Just by looking at the slopes alone, I know that they're going to cross one time. So let me just make sure. I actually wanted this to be -6x, sorry, so that should be positive, should be a positive 3x, sorry, that wasn't very good of me. Okay, so on this one, let's go ahead and graph these two together. Okay, so I'm going to start on this one. The y-intercept is -2. There's no denominator, so I'm going to make it an invisible 1. So I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. And I really hope that my lines end up being okay. Okay, and now this one, the y-intercept is at 2, so I'm going to go up at 2. And then right in front of the x, there's an invisible 1. It's not just negative, it's -1x, but for some reason we don't write 1s next to x. And then a whole number is always over an invisible 1. So that means that I'm going to have a slope of -1, so my left arm would be up in the air. And then I would go down 1 over 1. Oh, that's where they cross. So I just went down 1 over 1 one time, down 1 over 1 one time, and I saw that they crossed at 1, 1. So they crossed one time, and they'll never cross again because these are straight lines. So they will only cross one time. In this case, it was at the point 1, 1. Okay, and then I'll stop this one and start on the next one.